Okay, the principle is okay. How we are getting the energy, how we are transferring the energy, that is the principle. But with respect to application, you have to know. Transformer is there. Where you have to use? So while you working here in the colonies or in your near home, there is a transformer is there. What it will do actually? What is the purpose of the transformer there? What is the purpose of transformer in the colony? That is called distribution transformer. What it will do? 11,000 voltage. 11,000 voltage is stepping down to 415 volts. Okay, if you say single phase, 230 volts. It is a three phase. It is a single phase. So this transformer will convert 11,000 voltage into 415 voltage. Means stepping down. Step down transformer. Okay. So generally we are we are generating electrical energy. Where we are generating electrical energy? Electrical energy we are generating at a generating station. Okay. How much voltage we are generating? How much voltage we are generating? We are generating only 33K. 33K. So this 33K voltage, it is generating at generating station like any dam or thermal power or nuclear power. Okay. Hydro, Nagarjuna Sagar, Srisailam, their power is generating. So the voltage level, I'm talking about only voltage level. Voltage level is 33 kV. So this has to be increased to 132 kV. 33,000 has to be increased to 1,32,000. Who will do that one? Transformer. Okay. Here what is it doing transformer? Leveling up. That is step up transformer. Okay. So this step up transformer can be used at substations nearby the generating station, and stepping down as far as required mobile charger or any TV, any place, any industry, wherever we require less voltage. Okay, wherever we require more voltage, so we'll use step down as well as step up transformer. Okay, so here this smart board also. In smart board, what is the input voltage? 230 AC. So how much we require? 1000 voltage. So how much? 230 has to be increased to 1000. So stepping up, step up transformer. Okay, so this is the usage and function of the transformer. What it will do actually, transformer stepping up, stepping down. Application, where you have to use, you have to know what is the use actually. It will not do anything, only stepping voltage, stepping up, stepping down. Okay, power is same, power will not change, power is same. Input power is equal to output power. Okay, power into time is nothing but energy. So energy will not convert. Energy is transferred to one circuit to other circuit. That's all. So it will not change the power level. It will not change energy. It will not transfer the one form of energy into other form of energy. Okay, there is no rotating device is there in the transformer. Only electrical energy is available. That electrical energy is transferring from one circuit to other circuit. One circuit to other circuit, electrical energy is transferring. But what is the main concept here? Electrical energy concept transferring, but the voltage level is decreasing or voltage level is increasing. That's all. Okay, right. So this is about that is removed. Okay. Okay. So this is about mainly the idea. So as far as your syllabus is concerned, okay, what is the principle? Every device is there, na? Every machine is there. DC generator. What is the principle? You have to know the principle. Okay. So DC motor, what is the principle? Transformer, what is the principle? Induction motor, what is the principle? alternator. What is the principle? Okay, simple. Generator is there. For all generator, whether it is DC or AC, we are having only one principle. Motors are there na? For motors, we are having all the DC or AC motor, we are having only one principle. Okay, that principle you have to know. Okay, that principle we are converted into working. Principle is converted into working. How it is working? Why whenever I am giving supply, why it is rotating? What is the principle behind that? Why it has to be rotate? Whenever I am giving supply, why it has to rotate? What is the principle behind? Okay, so that you have to know. And transformer. Whenever I am giving the supply, why it is changing level of voltage? Why it is changing level of voltage? What is the principle behind that? Input is something 230. Output is I am getting 9 volts. How I am getting? And what principle it depends? Why it has to be? Okay. So the principle behind that are working, you have to know. And one more thing, you have to know about the construction. So the principle, the working has to be converted into one machine, one equipment. So the equipment which holds good that principle, the machine which holds good that principle, then it is working. Then I am calling it is a DC generator or DC motor or transformer. Okay, so principle, working, construction you have to know. Okay, DC generator is there. DC generator I am saying that mechanical energy is converted into electrical energy. Energy is converted into electrical energy. So mechanical energy means I am rotating. I am rotating or somebody, some external means is rotating. I am getting output voltage, generating electrical energy. So voltage I am getting. So how much voltage I am getting? On what way? On what parameters this voltage will depends? On what parameter this voltage will be depends? Can I get 1 voltage? I require 10 voltage. I require 230 voltage. I require 33 voltage. On what parameter depending? Mechanical energy into electrical energy. Okay, so that is nothing but you have to know that parameters. So EMF equation of the DC generator you have to know. In the same way, transformer is there. So transformer, what we are saying, electrical energy voltage or input voltage is leveling up or leveling down. Okay, so what is the value of that electrical energy? What is the magnitude and what values this E1 and E2 are leveling up, leveling down is take place and what parameter it depends. So then you have to know EMF equation of the transformer. Okay, so these are the topics. With respect to machines is concerned, you have to know total construction of, and what principle. Principle is converted into one device. That is nothing but DC generator. Okay, principle is converted to one device. That is nothing but induction motor. Principle is converted to one device. That is nothing but transformer. Okay, this concept you have to know. Okay, so how many questions you can frame? Nearly 10 questions or 8 questions you can frame from the machines. Okay, explain the working principle of the DC generator. Explain the working principle of the induction motor. Explain the working principle of alternator. Explain the working principle of DC motor. Okay, these are all the questions. And one more question. Explain the construction of the machine, DC machine. Explain the construction of the alternator. Explain the construction of the transformer. Okay, how many are there? These are 4, I think. These are 3 or 4. So 8 questions or 10 questions you can frame. And derivation of EMF equation of the generator, derivation of EMF equation of the transformer, and problems on these two. How many? Nearly 10 are there. 10 or 12 questions are there from the machines. So simple. Step by step I will tell. If you know DC generator, then it is easy to understand the AC generator. If you know DC generator, it is easy to understand the AC generator. Why? Just DC word is changed as AC. That's all. Generator same. So DC generator if you know, then AC generator okay. If you know transformer, you know the induction motor. Okay, if you know transformer, you know the induction motor. If you know the DC generator, you know the AC generator. Okay, so DC generator exact opposite is nothing but DC motor. DC generator opposite is nothing but DC motor. If you know DC generator, AC generator, okay. So how many are over DC generator, DC motor, induction alternator, induction motor, transformer. So everything one is linked to another. So first you listen. That's why with respect to syllabus, okay. First thing is DC generator. That you have to know. If you able to understand what is mean by DC generator, you can continue remaining. It is easy, very very easy. No need to worry. Okay. So what is DC generator now? DC generator. Why I am calling it here? So we are using DC supply, or we are getting DC output. We are getting DC as the output. Output is DC. So simple. What is the definition or what is the meaning of DC generator? Generator, I am saying. Generator means mechanical energy into electrical energy. Okay. So DC generator is a device. DC generator is a equipment which will convert mechanical energy into electrical energy. For your easy remembrance, what you have to write? Mechanical energy means rotating. So rotating, I have to rotate. You have to rotate. Or somebody external means has to be rotate. Okay. So generally who will rotate? Turbine will rotate. Turbine will rotate. Okay. So I will tell. So rotation. This is for you the remembering. For your remembrance. Okay. Generally you have to write down this one. This is for your easy remembrance. Rotation. What I am getting? I am getting electrical supply. This is for your remembrance, easy remembrance in your language. So, I have to rotate, somebody has to rotate. What I am getting? Electrical energy I am getting. Okay, now simple. So, here rotation, electrical supply. Now, what is the principle now? I have to rotate. What I have to rotate? What I have to rotate? Whether I have to rotate pen, I have to rotate pen, I have to rotate the wood or something. I have to get the output as the electrical energy. So for this, okay, so rotation is converted to electrical supply. See, for this, okay, I'm drawing a simple, we can say it is a simple generator. Okay, that is nothing but principle. Directly you will get principle. Okay, so I have to rotate the conductor actually. I have to rotate the conductor. This conductor has to rotate like this, clockwise direction or anti-clockwise direction. I have to rotate the conductor. Okay, so in conductor only we will get electrical energy. In this conductor only I will get electrical energy. In wood we cannot get. Wood is a insulator. In insulator we cannot get EMF or electrical energy or voltage. We cannot get here. Okay, in conductor only we are getting electrical energy. So I have to rotate conductor. I have to rotate conductor. Okay, I am having a conductor. Okay, this is made up of copper. Let us say it is a copper. So made up of copper. Copper I am rotating. Copper I am rotating. Can I get electrical energy? Where I have to rotate? Where I have to rotate? In a magnetic field I have to rotate. Okay, I am having conductor. I am rotating here. I cannot get. So the conductor has to rotate in a magnetic field. Where can I get magnetic field? Where can I get magnetic field? So we know, okay, we know magnets. Magnets, generally, if you take any magnet, piece of magnet, it has north pole, south pole. Okay, so magnetic flux leaves from north pole and terminates on south pole. This is the principle you studied in inter. North pole, south pole. Okay, they will not interact each other. Okay, they will not flow zigzag manner. Okay, so it leaves from the north pole and it terminates on south pole. Okay, that we know. Leaves from north pole, south pole. So I am taking now. So here I know we can get from the magnet. Okay, so that's why I have to get the magnetic field. Okay, so here I am using one north pole. This is a north pole magnet. This magnet consisting of north pole. So this is I am having another magnet. This is having another magnet which shows only the face is south pole. So north pole, south pole. Two poles are available. Now in between this field is available. Yes, we know. Why? Because from the north pole flux leaves and it terminates on south. Leaves and terminates. Leaves and terminates. Leaves and terminates. Leaves and terminates. Okay. From the north pole the flux leaves and it terminates on south pole. Okay. So field is available. Conductor is also available. Okay. Now I have to place this conductor. I have to place this conductor in the magnetic field. And I have to rotate this one. I have to rotate this one. Okay. So here it is a single conductor. So instead of using single conductor, I am using bunch of conductors. Bunch of conductors. Okay. Why I require bunch of conductors? Why? Because I have to get more voltage. More voltage. I need not one voltage. 1 rupee is it enough for ourselves? 1 రూపీతో ఓకేనా? ఒక రోజు గడుస్తుందా 1 రూపీతోని? గడవదు కదా. 100 రూపీస్ కావాలి, మీకైతే 1000 కావాలి. ఓకేనా? చెప్తున్నా ఎగ్జాంపుల్, అంతేనా? సో దట్స్ వై one conductor is not enough. I require more voltage. I require 1000 voltage, I require 2000 voltage, I require 10,000 voltage. So I don't require only one conductor. I am using now bunch of conductors. Okay, so now I am naming this bunch of conductors. Bunch of conductors is nothing but simple winding. Do you hear about winding? Whenever a fan burns, fan fails, fan get damaged, we'll use that word. Winding is burns. So winding is available in the fan. Yes? What is the meaning of winding? Bunch of conductors. Simple. Or group of conductors. Bunch of conductors or group of conductors is nothing but winding. What is the meaning? Can you define winding? Yes, group of conductors is known as winding. That's all. Okay, group of conductors or bunch of conductors. You can use either of one. Is nothing but winding. So instead of using one conductor, I am using bunch of conductors. I am using bunch of conductors. Okay, so bunch of conductors here. I am rotating bunch of conductors here. Okay, field is available. Field is available. I am rotating in the field. Yes. So that is the principle. Faraday's laws of electromagnetic induction. What happens actually? What happens? So whenever a conductor rotates in a magnetic field, కంపల్సరీ ఆ మ్యాగ్నెటిక్ ఫీల్డ్లోనే రొటేట్ చేయాలి. ఏదో ఇక్కడ నేను బయట నిలబడి కండక్టర్ ఇట్లా అంటే కాదు. ఓకేనా? కండక్టర్ హ్యాస్ టు రొటేట్ ఇన్ ఏ మ్యాగ్నెటిక్ ఫీల్డ్. ఇట్లా రొటేట్ చేస్తుంటే, so in the conductor an EMF will be induced. Okay, a conductor rotates in a magnetic field, an EMF will induce. ఎందుకు EMF ఎందుకు ఇండ్యూస్ అవుతుంది? Why and what principle? See, here flux is there, flux phi is there. What happens? So I am rotating here. What happens? See, I am rotating. What happens? So this conductor cuts the magnetic field. Yes, it is cutting like this. Flux is available. Flux is available. I am rotating this conductor. with a speed like this. With speed, how much speed? Generally 1500 revolutions per minute. 1500 revolutions per minute in general. Generally, in generating station, we'll use 1500 revolutions per minute. Okay, like this, 1500 revolutions per minute. If I rotate like this, then, okay, then an EMF will induce in this conductor. So how many conductors are having? Not a one conductor, I am having winding. Yes? How much speed we are rotating? Number of revolutions per minute. How much speed generally? In order to generate the 33 voltage or in generally. So constant value is 1500 revolutions, RPM. 1500 revolutions per minute. Okay. One more thing. So that is the principle. What is the principle? Whenever in a magnetic field, okay, a conductor placed in a magnetic field rotate with a speed or velocity. Okay, this conductor cuts the magnetic field. What happens to this conductor? This conductor is cutting the magnetic field. So whenever this conductor cuts the magnetic field, an EMF is induced in this conductor. If it is a one conductor, two conductor, bunch of conductors. Okay, so an EMF will induce in this conductor. That is the principle. Okay, you understand the principle now? So now the principle has to be converted into device. So I require conductor, I require group of conductors, I require a field. Okay, so now see, the amount of EMF induced is AC only. AC EMF will be induced, DC will not be induced. Okay, so whenever I am rotating this conductor in the magnetic field, an EMF will be induced. It is a AC only. DC will not induce. DC will not induce. Okay, it is a DC generator I am saying. I am saying DC generator. Yes, DC generator. I am saying DC generator. Then who will convert that AC into DC? EMF induced in the conductor is AC. This AC has to be converted into DC. Who will do? So one device called commutator. Commutator is a device which will convert AC to DC. It is fitted on the rotor. So I will tell what is meant by rotor, what is meant by stator. I will tell. Okay, right. So commutator will convert AC to DC. So whatever the amount of AC is converted into DC, DC means battery generally. Will represent, we have done so many problems. DC means like this, plus minus, which is having, we can represent 10 volts, 9 volts or 1000, 10,000 like this. So which is having plus and minus. So in order to collect this plus and minus, we require brushes. These brushes are placed on the commutator. Okay, one is called positive brush, other one is called negative brush. So these two brushes are multiple of two. Two brushes or four brushes or six brushes. Like this we are having. Two brushes or four brushes. These brushes are placed on the commutator. Okay, commutator will rotate like this. So brushes. Okay, so with respect to, okay, uh, parts or equipments are concerned. See, now, okay, I'm not having the magnets. Then what I have to do? These are the magnets. North pole, south pole, two magnets I have taken. I'm not having magnets. What I have to do? I'm not having magnet. What I have to do? Huh? Can I make magnets? I am not having magnets. Why? Because why we require magnets? Okay, in order to get the magnetic field, in order to get the flux, I require magnets. I am not having magnets. What I have to do? Can I make magnets by using iron piece? Huh? No? Yes. I can make magnet by using, okay, iron piece. So already in interview you are having. You take one piece of iron. It is a piece of iron. Okay. I am wounding here clockwise direction. Okay. I am applying DC supply, not AC supply, DC supply. DC voltage, it has plus, it has minus. Okay. Forget about how much voltage you are applying, but you have apply voltage. So here this pole will be act as the north pole. Each, okay, this downward is nothing but south pole. Whenever an iron piece, okay, wounded with copper wire, applied DC supply, then this iron piece will be act as the north pole, south pole. That is the concept actually. Why? Because I'm not having magnets. I'm not having magnets. So I'm making magnets. Okay. So instead of using magnets, I'm making magnets. I'm making magnets. So that's why here for this magnets, I'm having conductors which are wounded around the north pole, south pole. Okay. Why I wounded here? These are not magnet, but I am making magnet. I am making iron piece as the magnet. Iron piece as the magnet. If I wound in a clockwise direction, then it will be act as the north pole. In a anti-clockwise direction, okay, it acts at a south pole. And I have given supply as a DC. Okay, I have given supply as DC. So one pole is act as the north pole, one pole is act as the south pole. Okay, can I use more magnets? Yes, you can use multiple of 2. Here 2 pole. You can use here 1 more. You can use 1 more. That is as you wish, depending upon the size of the generator. So it is north, then it is act at the south, then it acts at the north, it acts at the south. Okay, north, south. Okay, flux where will move? From north to south, 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 north to south. So field is available. Okay, so instead of using two poles, poles, north south pole, I am using 4 poles, north pole, south pole, north pole, south pole. Instead of using this, okay, permanent magnets, I am making the magnets. Now here I am wounding here. It is not a single conductor. How many conductors we are having? So many group of conductors we are having. So can I say it is a winding? So poles has the winding. Yes, poles has the winding. Okay, and this I am rotating here, rotating the conductor. Conductor is not only single, it is also bunch of conductors. It is a winding. So this one winding. How many windings are available then in DC generator? How many windings are available then? Okay, 2 windings are available. One is in the field. Okay, one is in the field. Another one is as the conductor. Conductor, not only conductor. Okay, and now simple. What are the parts of the DC generator? Here field is not rotating. These are constant. Field is constant. Field is constant. It is not rotating. It is a stationary. Constant means stationary. Okay. Now stationary part of the DC generator is called stator. 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 Rotating part of the DC generator is called rotor or armature. Okay, rotating part. Why I have to rotate? Why I have to rotate? The main principle of the generator. What is the main principle of the generator? I have to rotate the conductor. In order to induce an EMF, you have to rotate. Why we require field? Why we require field? It is also now depends on the principle. Conductor has to rotate in the field. then only an EMF will be induced. Okay, now, okay, can I make a points now? What we require in order to generate an EMF? What we require? In order to generate an EMF, what we require? In order to generate EMF, what we require? We require conductor or group of conductors. It is a single conductor, group of conductors. Okay, next one, I require magnetic field. Yes, is these two are enough? I'm having conductor, I'm having field. Can I get the EMF? Or we require, what is that? I'm having conductor, I'm having field. Okay, EMF will be generated? No. So, conductor has to rotate in a magnetic field. So that means rotation is required. What is the meaning of that one? Rotation is required. Conductor. So how many we require? One is we require conductor or group of conductors. Second one is we require field. We require field. Flux I require. Okay. Third one is speed. Okay. Speed. I have to rotate now. Number of revolutions per minute. So these three things are required to get the EMF, to generate EMF, to induce an EMF. These three, we cannot get a EMF. Okay, if anyone is missing, we cannot get EMF. We cannot generate, we cannot induce. Okay, magnetic field is available, conductor is available, but I am not rotating. No. Okay, the conductor is rotating, but magnetic field is not available. No, I cannot get. Magnetic field is there, but I am rotating. But what I am rotating wood. It's not a conductor. It is a wood. Wood, if I rotate wood in a magnetic field, what happens? It's not a conductor. There is no EMF here. Okay, so these three things are required to generate an EMF. Okay, now with respect to construction of the DC generator, okay, so we have to convert this one. This principle is there now. I have to rotate the conductor. That is nothing but winding. Okay, stationary part. Field. Where is the field is located? In the stationary part. It is not rotating. Why we require field? To get the EMF. We require field. Why we require conductor? Why we require conductor? In the conductor only. So the main concept is we have to get the electrical energy as output. In order to get the electrical energy, in order to get the induced EMF, we require these all three things. Okay, that is the main concept. If anyone is missing, no EMF. Okay, EMF. So after getting it is a DC generator, after getting this is the minimum. After getting the EMF induced, okay, it is AC to be converted into DC by using some device. Okay, that has to be collected by some device. The two are the one is commutator, another one is brush. Okay, so these are the three things you require. See the diagram. Construction of the DC generator you have to draw. So in the exam, construction is very, very important. Okay, that means this diagram is very, very important. Okay, so everyone I will explain now. No need to worry. Explain. Okay, so this outermost is there, na? This outermost. So this outermost is called yoke. Yoke. Why we require yoke? In the yoke only, in the outermost circle, in yoke only, we will fit the poles. North pole, south pole, north pole, south pole are there. The north pole, south pole, north pole, south pole. Four I am saying. that are fitted to the yoke. ఎక్కడ ఒక దగ్గర ఏం చేస్తాం, ఫీల్డ్స్ ఎక్కడ పెడతాం, నువ్వు ఇక్కడ పెడతాం, ఇలా ఇలా పెడతాం, ఇలా ఫిట్ చేస్తాం పోల్స్. ఎందుకు పోల్స్, ఎందుకు తెలుగు యూజ్ చేస్తున్నామ్మా, ఎందుకంటే కొంతమందికి అర్థమవుతలేదని చెప్పినారు నాకు, అందుకని తెలుగు యూజ్ చేస్తున్నా. ఓకే, పోల్స్ ఎందుకు, వై వి హ్యావ్ టు యూజ్ ది పోల్, వి రిక్వైర్డ్ ఫ్లక్స్, వి రిక్వైర్డ్ మ్యాగ్నెటిక్ ఫీల్డ్. ఓకే, ఫ్లక్స్ కావాలి కదా, ఫ్లక్స్ కోసము మనకు పోల్స్ కావాలి, మ్యాగ్నెట్స్ కావాలి. ఓకే, ఇప్పుడు నేను ఇక్కడ ఏం చేశాను చూడండి, మ్యాగ్నెట్స్కి నేను ఏం చేశాను, ఇక్కడ దీనికి పోల్స్కి ఏం చేశాను, రౌండ్ చేశా. ఐ రౌండెడ్ ది కాపర్ వైర్ ఇయర్, ఐ రౌండెడ్ ది కాపర్ వైర్. వై? So these are the actually iron piece. So these iron piece are converted into magnets. Okay, as the north pole, south pole. See, it is wounded as clockwise. It is wounded as anti-clockwise. Clockwise, anti-clockwise. If we wound as the clockwise, it is act as the north pole. If it is wound as the south anti-clockwise, it is act as the south pole. And see, one terminal is coming here. North pole, south pole, north pole, and we are bringing out. Two terminals bringing out, which are used to, we are giving DC supply. Now I am making this and పోతుందమ్మా. So here it is a DC generator. So this is nothing but yoke. Outermost orbit is yoke. You have to draw. Okay. For that you require కంపాస్ అంటావా, ఏమంటావు, ఏదో ఒకటి దాంతో వేయాలి. ఇక్కడైతే అమ్మాయిలు అయితే బ్యాంగిల్స్ ఉంటాయి, బ్యాంగిల్స్ లేవంటే మనం ఏం చేయలేం. ఓకే, రైట్. ఓకే, యూ రిక్వైర్ టు డ్రా దిస్. వన్స్ ప్రాక్టీస్. ఓకే, ఐ విల్ ఎక్స్ప్లెయిన్. వెయిట్, ఫస్ట్ లిజన్ ఆల్ ది పార్ట్స్. ఓకే, రైట్. సో దిస్ ఈస్ పోల్. సి, okay, actually this is pole. Up to here it is a pole. It is a pole. It is a pole. Okay, now see, this is there na, this is called pole shoe. Okay, pole shoe. So what is the purpose of using this pole shoe? Amma, what is the purpose of using pole shoe? Pole is okay, pole is nothing but what is the use of pole, which will deliver the flux or which will absorb the flux. If it is a north pole, what happen, flux will be delivered. If it is a south pole, what happen, flux will be absorbed, like this. Okay, I will erase, no need to worry, first listen first. Okay, so like this flux is available. So total, so see, where are the conductors? Conductors are here. So these conductors cut the magnetic field. While rotating, this conductor is cut the magnetic field. Okay, so this is the way. Okay, so this is pole, this is pole, this is pole shoe. Okay, so where are the conductors? Conductors are in a rotor. See, like this. What is the use of this pole shoe? I am telling. What is the use of pole shoe? So only, for example, there is no pole shoe. There is no pole shoe. See here. There is no pole shoe. Only pole is available. Conductors are circle. The rotor it is. Only you are having pole and rotor. Okay. See, what is the distance between here to here? More decreasing and getting minimum and again increasing. Yes, the distance between the pole and rotor is increasing and decreasing, getting minimum and increasing. There is no, okay. So what happens? The flux is distributing unequally. Flux is distributing unequally. So now I am using pole shoe now. I am using pole shoe. See the distance between every point. The distance between every point is equal now. See, every point it is equal. Otherwise you observe here. Every point is equal. Every point is equal. Every point. Wherever it is distributing, the every point is equal distance from the this pole shoe face to the rotor conductors. Pole shoe face to the rotor conductors. So what is the function of this pole shoe now? What is the function of pole shoe now? So in order to distribute the flux to the conductors equally, okay, in order to distribute the flux to the rotor equally, so we have to use pole shoe. Pole and pole shoe. What is the function of pole? Which will deliver the flux or which will absorb the flux. What is the function of pole shoe? Which will distribute a magnetic field equally to the conductor. Okay, this pole and pole shoe are fitted to the yoke. It is a yoke, outermost one. This one is a yoke. We are fitting this pole here. Okay, that is called a riveting antam. Riveting. Fitting and riveting. Riveting is the technical word. Riveting antam. Okay, riveted to this yoke. Okay, now one more thing. What are the remaining equipment is available here? Winding. Winding is available. Okay, why we require winding? If we wound the winding around the poles, then this pole will be act as the magnet. So these are not permanent magnets. We are making cast iron into magnets. Okay, so in stator, how many elements are there now? How many parts you are having? So mainly DC generator consisting of two parts. One is called stator, other one is called rotor. Stator is nothing but stationary part is called stator. Stator అంటే స్టేషనరీ పార్ట్ అంటే అది రివాల్వ్ కాదు. ఫీల్డ్ ఇలా ఉంటుంది అంతే. ఫీల్డ్ నార్త్ పోల్ సౌత్ పోల్ నార్త్ పోల్ ఇలా ఉంటుంది అంతే. దాని మధ్యలో రోటర్ పెడతాం మనం, రోటర్. సో రొటేటింగ్ పార్ట్ ఆఫ్ ది DC generator is called rotor. Mainly two. Okay, stator. In the stator, what are the different parts you are having in the stator? In the stator we are having only three parts. Stator, one is called pole, second one is called pole shoe, third one is called winding. Winding. So it is a field, north pole south pole field అంటున్నాం కదా, magnetic field. Can I say field winding? Can I say field winding? Yes. Now, how many parts you are having in the stator? One is called pole, second one is called pole shoe, third one is called field winding. Field winding. Why? Because it is north pole, south pole, north pole, south pole. Instead of saying winding, we are saying field winding. How many are there? Three parts are there in the stator. One is called pole, second one is called pole shoe, third one is called winding, field winding. What is the usage of this? You have to write down. These are the parts. After writing the part name, what it is uses? What is the use? Why we require pole? Pole will generate the flux. Pole will absorb the flux. Pole will deliver the flux, will absorb the flux. Okay, pole shoe. So, which will distribute flux equally to the conductor. That's all. Single line. మీరు మొత్తం ఏదో పెద్ద స్టోరీ అవసరం లేదు. పోల్ అనే డివైజ్, పోల్ అనే పార్ట్ ఏం చేస్తుంది? డీసీ జనరేటర్ ఏం చేస్తుంది అది రాయాలి అంతే. పోల్ షూ ఏం చేస్తుంది? వైండింగ్. వైండింగ్ ఏం చేస్తుంది? మనకెందుకు ఫీల్డ్ వైండింగ్ ఎందుకు? వీఆర్ మేకింగ్ ది క్యాస్ట్ ఐరన్. దట్ పోల్స్ is not a permanent magnets. We are making them as the magnet. That's why we require winding. Okay. So over stator, over stator. Three parts are over. అది మరి మంచిగా డ్రా చేయండి. మీకు ఇప్పుడు ఇక్కడ వచ్చినా రాకున్నా ఎగ్జామ్లో మాత్రం జాగ్రత్తగా డ్రా చేయండి. ఎందుకంటే మీకు అది కావాలి కదా. లైక్ దిస్ యూ హ్యావ్ టు కీప్ దిస్ వన్ ఇలా అంటావు కదా. ఏదో ఒకటి నీ పేరు, అదేం పేరు. రైట్. ఓకేనా? సో బై యూజింగ్ దట్ యూ డ్రా ది డయాగ్రామ్. ఇక్కడ ఏదో రఫ్గా డ్రా చేస్తా అంటే రఫ్గా డ్రా చేయి. బట్ యూ హ్యావ్ టు నో వాట్ ఆర్ ద పార్ట్స్ యూ ఆర్ హ్యావింగ్. ఆ పార్ట్స్ తెలియాలి కదా. 1 2 3 4 ఇట్లా ఎన్ని ఉన్నాయి? హౌ మెనీ ఆర్ దేర్ ఇన్ ద స్టేటర్? 3 ఆర్ దేర్. వాట్ ఆర్ దే? పోల్, పోల్ షూ, వైండింగ్. ఇంకొకటి కూడా ఉంది, యోక్. యోక్ ఉంది కదా, యోక్. యోక్ ఇస్ నథింగ్ బట్ దిస్ వన్. ఇగో ఇది ఉంది కదా, దిస్ టోటల్ దిస్ పార్ట్. సో వాట్ ఇస్ ద ఫంక్షన్ ఆఫ్ దిస్ యోక్? వై we require? Which will give mechanical strength to the DC generator. First one, yoke will do two things. One is which will give the mechanical strength to the generator. Second one, poles are fitted to the yoke. అంతే కదా. ఇప్పుడు చూస్తే తెలిసిపోతుంది కదా పోల్స్ ఏంటి ఫిట్ చేస్తున్నాం. ఇక్కడ ఇక్కడ యోక్ ఇలా ఉంటుంది, ఫిట్ చేస్తాం పోల్ ఇట్లా. ఓకే, బై యూజింగ్ నట్ బోల్ట్ లైక్ దిస్ ఫిట్ చేస్తాం. ఇలా మళ్ళీ ఇలా 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 ఫిట్ చేస్తాం యోక్కి. ఓకే రైట్. ఇది అయిపోయింది. ఓకే, 3 ఆర్ ఓవర్. వాట్ ఇస్ ద యూస్? వాట్ ఇస్ ద మెటీరియల్ వీఆర్ యూజింగ్? మెటీరియల్ కూడా రాస్తే రాయండి. మెటీరియల్ యోక్, క్యాస్ట్ ఐరన్. యోక్ ఇస్ దేర్, క్యాస్ట్ ఐరన్. పోల్, pole shoe, it is also cast iron, or you can use cast steel. Cast iron, cast steel. Okay, iron piece తెలుసు కదా. ఐరన్ పీస్కి సమ్ కెమికల్స్ సమ్ యాడ్ చేస్తారు. యాడ్ చేస్తే దాన్ని క్యాస్ట్ అవుతుంది. క్యాస్ట్ ఐరన్ అంటే మరి కెమికల్ మనకొద్దు. ద నేమ్ ఇస్ క్యాస్ట్ ఐరన్, క్యాస్ట్ స్టీల్. ఓకే, so this is yoke is made up of cast iron. Poles are made up of, pole and pole shoe are made up of cast iron or cast steel. Okay, right. Then winding. Winding means always copper. Okay, copper. Winding is made up of, field winding is made up of copper. Ante the function rayali, material rayali. Right. Next, rotor. Okay, rotating part of the DC generator is called rotor. సింపుల్, మనకు తెలుసు. రోటర్లో ఏముంటాయి? కండక్టర్స్ ఉంటాయి కదా. ఒక కండక్టర్ ఉంటుందా? ఎన్ని ఉంటాయి? బంచ్ ఆఫ్ కండక్టర్స్ ఉంటాయి. ఏమంటాం దాన్ని? వైండింగ్ అంటాం. సో రోటర్ కూడా మనకి వైండింగ్ ఉంటుంది. రోటర్లో కూడా వైండింగ్ అంటే కండక్టర్స్ కదా. గ్రూప్ ఆఫ్ కండక్టర్స్, బంచ్ ఆఫ్ కండక్టర్స్ ఈజ్ నోన్ యాజ్ వైండింగ్. 2 మార్క్స్ అడుగుతాడు, వాట్ డూ యూ నో అబౌట్ వైండింగ్? or define winding. Group of conductors is known as winding. Bunch of conductors is known as winding. Okay, more than 2 conductors is nothing but winding. రైట్. ఓకే. రైట్. ఇప్పుడు ఇక్కడ చూడండి, ఇప్పుడు దిస్ ఇస్ ది కట్ సెక్షన్ యాక్చువల్లీ. ఐ హావ్ కటెడ్ ది డీసీ జనరేటర్ ఆఫ్. సో ఫ్రంట్ వ్యూ యు ఆర్ సీయింగ్. ఫ్రంట్ వ్యూ ఆర్ సీయింగ్. ఓకే. నేను ఇప్పుడు ఇది డయాగ్రామ్ చూపిస్తా నేను యాక్చువల్గా. ఓకే. టోటల్ డయాగ్రామ్ డీసీ జనరేటర్. సో హియర్ సి rotor has shaft. So this is center is there na, this is called shaft. షాఫ్ట్ అంటే ఇలా సింపుల్గా ఇలానే ఉంటుంది. షాఫ్ట్ అంటే ఇలానే ఉంటుంది, సింపుల్, ఒక పెన్ లాగా పెద్దగా ఉంటుంది ఇంత. ఓకే. షాఫ్ట్. ఆన్ ది షాఫ్ట్ we will fit rotor slots పెడతాం మనం. రోటర్ స్లాట్స్ అంటే హియర్ లైక్ దిస్. ఇన్ దిస్ షాఫ్ట్ these are the slot 1, slot 2, slot 3, 4, like this. How many slots are there? ఇలా డ్రా చేయండి రోటర్. చేత్తోనే డ్రా చేయండి, ఎగ్గా డ్రా చేయండి. సో దీస్ ఆర్ ద స్లాట్స్. సో ఇన్ ద స్లాట్స్ వాట్ విల్ కీప్? విల్ కీప్ ది ఇన్ ద స్లాట్స్ విల్ కీప్ ది కండక్టర్స్ ప్లేస్ చేస్తాం అక్కడ. కండక్టర్స్ ఎన్ని కండక్టర్స్ డిపెండింగ్ అపాన్ ది వన్, దానికి ఒక ఫార్ములా ఉంది, అది మనకు అనవసరం. ఓకే. విల్ హౌస్ ది కండక్టర్స్ హియర్. ఇగో ఇదే కండక్టర్స్. ఇగో ఇక్కడ మీకు ఈజీగా ఉండడానికి 2 కండక్టర్స్ చూపిస్తున్నారు. 2 కండక్టర్స్ ఆర్ అవైలబుల్ హియర్. 2 కండక్టర్స్. సో హియర్ ఫ్రంట్ వ్యూ. ఈ పెన్ ఇప్పుడు ఇలా ముందు చూస్తే ఏమవుతుంది నీకు? యు ఆర్ సీయింగ్ ఓన్లీ దిస్ వన్, బట్ కండక్టర్ ఇస్ దిస్ మచ్ ఆఫ్ లెంత్. ఓకే. ఫ్రంట్ వ్యూ యు ఆర్ సీయింగ్ ఓన్లీ డాటే కనబడుతుంది కదా, అందుకనే డాట్ డ్రా చేయాలి. డాటే కనబడుతుంది కాబట్టి మీకు డాట్ ఎక్కడ కనబడుతుంది కదా, సో డాట్ డ్రా చేయాలి. బట్ లెంత్ ఎంత ఉంది? we don't know. Okay, right. So conductors are housed in the slots, rotor slots. So rotor contains rotor slots where conductors are housed, where conductors are placed in the rotor slots. Okay, right. So this rotor is made up of cast iron. This rotor is made up of rotor slots are made up of cast iron. Okay. So in the rotor slots we will keep the conductors. So these conductors are made up of copper. మళ్ళీ కండక్టర్ అనగానే కాపరే, ఇంకా వేరే యూజ్ చేయం మనం. క్యాస్ట్ ఐరన్ అలా యూజ్ చేయం, ఓన్లీ కాపరే. కండక్టర్ అంటే కాపరే. సో కాపర్స్ are used. Copper conductor is placed in the rotor slots. ఓకే, రైట్. సో ఇది మళ్ళీ చెప్పాను, ఇది ఫ్రంట్ వ్యూ కదా, కట్ సెక్షన్ కదా. కట్ సెక్షన్ కాబట్టి మనం ఇది ఇలానే డ్రా చేయాలి. యాక్చువల్గా ఇది రోటర్ అనుకుంటే ఇవి ఇక్కడ పక్కన సైడ్కి ఉంటుంది, ఏది ఈ కమ్యూటేటర్. నేను చూపిస్తాను మీకు, ఐ విల్ షో దట్. ఓకే. మనము టాప్ వ్యూ చూస్తే తెలుస్తుంది, ఫ్రంట్ వ్యూ చూస్తే ఇట్లనే కనబడుతుంది. టాప్ వ్యూ పైనుంచి చూస్తే మీకు కనబడుతుంది ఇది. ఓకే, రైట్. సో దిస్ ఈజ్ దేర్ నా, దిస్ ఈజ్ కాల్డ్ కమ్యూటేటర్. నేను రావట్లేదు. ఇప్పుడు వచ్చింది. రైట్. సో హియర్, సో దిస్ ఈజ్ కాల్డ్ కమ్యూటేటర్. It is a commutator also in a circular. See, so this commutator is not a single device. So I am bringing Right, correct for me. 298.6 is the voltage. Next one is wave connected A is equal to 2. Correct. Yeah. Okay. So after getting the value, you keep this one in a box. AJ is equal to 298.6. AJ is equal to 896 volts. Keep in a box. Okay, let the value choose the they will give 8 out of 8. Yes. Okay. So this is the way of handling the problem. Okay. Right. Everyone has to do. This is the second problem you have to do. Very huge syllabus ఉందమ్మా మీ బీటెక్కి అన్ని కాన్సెప్ట్ అన్ని యూనిట్స్ చదవాలి ఏది చదువుకున్నా కూడా నువ్వు ఫెయిల్ అవుతావు ఒకసారి ఫెయిల్ అయితే హచ్ కుక్క లాగా నీతో వస్తుంది తెలుసా హచ్ కుక్క తెలుసు కదా సెకండ్ ఇయర్ చదువుతావు బీటెక్లీ బ్యాక్ లాగా అంటావు థర్డ్ ఇయర్ చదువుతావు బీటెక్లీ బ్యాక్ లాగా అంటావు ఫోర్త్ ఇయర్ చదువుతావు బీటెక్లీ బ్యాక్ లాగా అంటావు ఇక బీటెక్లీతో వదిలిపోదు ఇక సార్ ఓన్లీ బికాస్ ఆఫ్ బీటెక్లీ నేను ఇంకా ఫోర్త్ ఇయర్ కాలేదు సార్ అని కూడా వై బికాస్ ఇట్ ఈస్ నాట్ సిఎస్సి నాట్ సిఎస్సి కదా నువ్వు చదవవు ఇంకా ఇప్పుడే ఫస్ట్ సెమిస్టర్ చదవకుంటే నువ్వు ఇంకెప్పుడు చదువుతూ థర్డ్ ఇయర్ చదువుతావా బీటెక్లీ అప్పుడు మొత్తం నీ ప్రోగ్రామింగ్ ఓకే డేటాబేస్ ఫ్లాట్ ఈబిఎంఎస్ సి లాంగ్వేజ్ పైథాన్ అడ్వాన్స్డ్ లాంగ్వేజెస్ అవన్నీ ఉంటాయి అవన్నీ చదువుకుంటా ఇప్పుడు ఈ టెక్నికల్ చదవప్పుడు ఇక ఇది వదిలిపెట్టు థర్డ్ ఇయర్ రాస్తావు ఫోర్త్ ఇయర్ రాస్తావు అయినా పాస్ అందుకోసం ఏ సబ్జెక్ట్ అయినా ఆ సెమిస్టర్నే కంప్లీట్ చేయాలి బ్యాక్ లాగు పెట్టుకోవద్దు బ్యాక్ లాగ్ అనేది పెట్టుకోవద్దు ఏ సబ్జెక్ట్ అయినా సరే మినిమం మార్క్స్ వచ్చిన యూఎస్ ఆర్ సంథింగ్ అక్కడ కొన్ని యూనివర్సిటీస్ బ్యాక్ లాగ్ ఉంటే తీసుకోవు నీకు జిఆర్ఈ టోటల్ ఎంత మంచుకున్నా సరే బ్యాక్ లాగ్ ఉందనుకో నీ అప్లికేషన్ ఫామ్ తీసుకెళ్ళి చెత్త ముద్దలు పడేసి ఓకే యు గాట్ 95/100 ఇన్ ఇంజనీరింగ్ ఓకే ఈవెన్ you are having TOEFL and GRE very good score like 700 to 690 okay GRE 720 కి 680 వచ్చినా మీకు జీరో బ్యాక్లాగ్స్ ఉన్నాయి మీకు బ్యాక్లాగ్స్ ఉన్నాయి జీరో కాదు బ్యాక్లాగ్స్ ఉన్నాయి అంటే ఈ అప్లికేషన్ ఫామ్ చెత్త గుట్టలో పడేస్తారు రిజెక్టెడ్ ఏ కంట్రీ అయినా నాట్ యుఎస్ఏ కాబట్టి మన పర్సెంటేజ్ ఇంపార్టెంట్ ఎట్ ది సేమ్ టైం బ్యాక్లాగ్స్ ఉండదు అది కాన్సెప్ట్ ఇప్పుడు ఈ సబ్జెక్ట్ ఉంది ఓకే మినిమం మార్క్స్ అయినా రాని క్లియర్ చేసి బ్యాక్లాగ్ వద్దు మినిమం మార్క్స్ అయినా రాని క్లియర్ చేసి ఎందుకంటే ఇది నాన్ సిఎస్సి కదా నాన్ సిఎస్సి కాబట్టి మినిమం 6 మార్క్స్ అయినా రాని అందరికి వదిలిపెట్టేసి క్లియర్ అవుతుంది కదా, బ్యాక్ బ్యాక్ రాదు కదా. అది ఇంగ్లీష్, తర్వాత మ్యాథమెటిక్స్, ఫిజిక్స్, డ్రాయింగ్ ఇలాంటి సబ్జెక్ట్స్ కి మినిమం వచ్చినా పర్లేదు. బట్ సంథింగ్ ఈజ్ బెటర్ దాన్ ది ఫెయిల్ కదా. కాదా? సంథింగ్ ఈజ్ బెటర్ దాన్ ది ఫెయిల్. అది గుర్తుపెట్టుకోండి. పాస్ ఓకే, ఫెయిల్ అంటే నువ్వు అంత వేస్ట్ అంటే ఫెయిల్ అంటే 40 మార్కులు పాస్ అయితే 39తో నువ్వు ఫెయిల్ అయితే ఎవరు బెటర్? వాడే బెటర్. పాస్ అవుతే బెటర్ 40 మార్కులు వచ్చిన. కాబట్టి ప్లీజ్ ట్రై టు reduce the failures in individual exam, individual semester. పాస్ అయిపోవాలంతే. లేదురా బాబు ఇంకా తక్కువ మార్క్స్ వచ్చేటట్టుంది తర్వాత రాసుకుంటా అంటే వద్దు. తర్వాత అంటే తర్వాతనే అవుతుంది. అది తర్వాత భూకంపం వస్తే కదా, రేపు మనకు తెలియదు ఎలా ఉంటుందో. ఈ సెమిస్టర్ సబ్జెక్టు ఈ సెమిస్టర్ అయిపోవాలి. ఈ సెమిస్టర్ లో నీకు పర్సెంటేజ్ ఓకే తక్కువ రాని, 60% రాని, 65% రాని, ఏమి కాదు. టోటల్ అగ్రిగేట్ చూస్తారు, 5 year టోటల్ చూస్తారు. ఇప్పుడు మీ దాంట్లో సబ్జెక్ట్ వదులుకోకుండా జేఎన్టీ కాకినాడలో లేవా సబ్జెక్ట్ వదులుకోవడం తెలుసా మీనింగ్? అదే టోటల్ 4 years లో మీకు ఫర్ ఎగ్జాంపుల్ ఒక 80 సబ్జెక్ట్స్ ఉన్నాయనుకోండి. ఓకే, టోటల్ 4 years లో 80 సబ్జెక్ట్స్ ఉన్నాయనుకోండి. 4 years లో 80 అయితే కదా 6 అంతే కదా, 6 56 సబ్జెక్ట్స్ అనుకోండి. ఒక 2 సబ్జెక్ట్స్ మీరు వదులుకోవచ్చు. అంటే ఫెయిల్ అయినా పాస్ అయినా ఎగ్జామ్ రాసినా రాయకుండా ఏం కాదు. అలా ఉందా అవుతుందా మీకు తెలుసా? తెలుసు. Only coming to college and listening the class and it is the full day. Right? Yes, Arani? How much you got? You tell me now. Given data you written? I please make it development. What the value of gel you tell me? A wave connected armature winding has 19 slots with a 44 conduction per slot. If the flux per pole is 0.066 Weber and the number of poles is 8, calculate the speed at which generator should run to give 564 volts. Calculate the speed of the armature lap current. Okay, there are 2 questions. One is you have to find out the speed at which EG is equal to this one. Speed at which armature is connected to lap. Okay, you written this. We'll write down. We will solve this. The solution given data. Given data 0.0 ఇంకా ఇంకేమి ఇచ్చింది? జెడ్ ఇవ్వలేదు కదా, జెడ్ ఇచ్చిందా? జెడ్ చెప్తాను. ఓకే, ఇంకా ఎన్ని ఇచ్చాడా? ఎన్ని ఇవ్వలేదు, ఎన్ని కనుక్కోవాలి. ఇంకేమి ఇచ్చింది మరి? బి ఇంకా So here, how can you find out the Z value? Z value is not given actually. He is given how many slots are there. Okay, slots are there now. You know slots for the rotor. Number of slots. Slots. How many slots are available? Number of slots. How many? 19. 19 slots are available. So in each slot, how many conductors are available? In each slot? 44. So 44. So you have to multiply. So in each slot, the meaning is How many slots are there? 19 slots are there. 19 slots, rows and slots are how many? 19. So you have to get Z value. So in each slot, how many conductors are there? Here like this. 44 are there. Each slot. Okay, 44, 44, 44. How many are there? 19. So how can I nothing but number of slots into number of slots, number of conductors per slot. Okay, what is the formula for Z here? Number of slots into number of conductors per slot. That is given by 19 into 44. Atena? Enta? 36. 6. Okay, this is the mean. Now, the given find out the speed, it will show an actual. Find out speed at which it is equal to 564. 564. That is the first question. Second question. Find out speed at the total winding is connected as lamp. A is equal to P. There are two questions are given. This is the first, this is the two. Okay, so now here A is equal to 8. You have to find out this. EG is not changing, but only A value is changing. What the value is P. So write down the formula actually. EG is equal by J N P by 68. Pi is 0.066. N is nothing but 836. N is nothing but we have to find out. P is nothing but 8 by 68. A is equal to 8. So here EG is equal to 564. So from this N is equal to 564 into 60 into 8 by 0.066 into 836 into 8. What the value? 613. How much? 613.3. 613.3. P cannot be in the decimal, so you round it to 613. The speeds. Number of 613 revolutions per minute. Okay. Next one is asking find out the speed. Yet A value is equal to P. A value P na. Right? A value wave on ల్యాప్ వన్ అంటే ఏ ఈక్వల్ పీనే కదా మరి అది ఏ వాల్యూ ఈక్వల్ పీ బదులు వేవ్ అయింది కాదు క్వశ్చన్ చదవండి ఒకసారి A wave connected armature winding has 19 ohm is the flux per volt and the number of volts is 8 calculated speed is okay. Calculated speed is armature. Okay. There is no question. Only one question is asked. One question is asked. This is only asked. Okay question. Okay. So the answer is how much? 613. Okay. So this is the way. So direct question, all the parameters are given in the question. Okay. You have to simple remember. Okay. Exam lo first question ivalane given data is important. Write down the given data. Okay. Given data after the formula. What are the formulas are applicable to above problem? After that, substitute in the formula. Last, write down the value of the answer, keeping a box. Then you will get 8. You only mix a formula to given data, you will get 2 marks. Given data, 2 marks, 0, 2 marks, 2 marks extra. Given data, you have to write down compulsory. Okay? DC machine construction, DC generator is equal to DC motor. So constructionally there is no difference between generator and motor. DC generator and DC motor. Constructionally, I can use DC generator as DC motor. I can use DC motor as a DC generator. Okay, vice versa. So construction, there is no need to study again DC motor construction. Already over DC generator construction. DC. Okay, right. So now, what I mean by DC motor, how it works. How it works. DC motor. So what the meaning of motor? Motor is nothing but simple. Motor means you have to remember the car. Supply, voltage. So it is a device which will, or it is a electrical, the machine which will convert the electrical energy into mechanical energy. So construction is a construction is everything. No need to differ. North pole, south pole. Here I am walking. Okay. So conductor is also. Conductor not only single conductor, there are a bunch of conductors. But principle is different. There, DC generator I am rotating. There I am rotating. I am getting output of the electrical energy. Here I am applying the voltage. I am giving electrical energy as the input. Electrical energy input. So electrical energy input means already this conductor carries the current. Electrical energy input means electrical supply is available. What is the meaning of supply is available? So the conductor carries the current. Conductor has the voltage. అంతే కదా ఇన్పుట్ మనం ఏమి ఇచ్చాం పవర్ ఇచ్చాం కదా పవర్ అంటే వోల్టేజ్ ఇందులో వోల్టేజ్ ఉంటుంది కరెంట్ ఉంటుంది ఓకే వోల్టేజ్ ఉంటుంది కరెంట్ ఉంటుంది ఎవ్రీథింగ్ ఈజ్ అవైలబుల్ ఇన్ ద కండక్టర్ సో వాట్ ఇస్ ద ప్రిన్సిపల్ ఓకే ఏ కరెంట్ క్యారింగ్ కండక్టర్ placed in a magnetic field where it is actually in the magnetic field. Okay, magnetic field is available. For the generator అప్పుడు కరెంట్ ఉంటుంది అందులో మనం దాన్ని రొటేట్ చేస్తే అందులో EMF వస్తుంది. We are rotating the conductor, then EMF is generated. ఇక్కడ అది కాదు ఆల్రెడీ సప్లై ఇస్తున్నాం ఎలక్ట్రికల్ ఎనర్జీ ఇస్తున్నాం నువ్వు రొటేట్ చేయట్లేదు నువ్వు సప్లై ఇందులో కరెంట్ ఉంది ఓకే కరెంట్ ఈజ్ అవైలబుల్ ఇన్ ద కండక్టర్ సో దీన్ని నువ్వు రొటేట్ చేయట్లేదు కరెంట్ క్యారింగ్ కండక్టర్ ప్లేస్డ్ ఇన్ ఏ మ్యాగ్నెటిక్ ఫీల్డ్ వాట్ హ్యాపెన్స్ విచ్ విల్ ఎక్స్పీరియన్స్ ఏ ఫోర్స్ ఓకే అంటే ఇప్పుడు ఈ కండక్టర్ ఏమవుతుంది ఈ కండక్టర్ మనం ఫీల్డ్ లో ఉంటే ఏమవుతుంది ఇట్ విల్ స్టార్ట్ మూవింగ్ ఓకే సో conductor carries the current which is placed in a magnetic field లో కండక్టర్ పెట్టామా what happens which will experience a force the force అంటే ఎలా ఉంటుంది ఈ రోటర్ ఎలా ఉంది కదా not only single conductor one conductor two conductor three చెప్తాను example 3 4 5 6 like this are group of conductor bunch of conductor winding ఉంది కదా so what happens here north pole south pole so flux is flowing like this not only 2 poles are there it may be 4 poles or 6 poles okay now see how the flux is flowing like this how the conductor is in the conductor current is flowing like this inside conductor is flowing like this okay how the flux like this so it means here like this like this it may be left hand it may be right hand okay one is direction of flux other one is direction of current other one is force okay 3 ఉంటాయి like this Okay, one is direction of current. Okay, another one is direction of flux. This one is force. Thumb indicates force. Okay, so it means what happens whenever flux is flowing like this. In this conductor, what happens? Current flowing inside. Why? Because left side. Here, current is coming outside. Current is coming, going inside. ఇలా ఉంటుంది కదా కండక్టర్ గోయింగ్ ఇన్సైడ్ లెఫ్ట్ సైడ్ మళ్ళీ మనం ఇది ఏం చేస్తాం అని అంటాం కదా ఓకే ఇన్ దిస్ కండక్టర్స్ కరెంట్ ఈజ్ అవుట్ సైడ్ ఓకే హియర్ సి ఇట్ ఈస్ గోయింగ్ టువర్డ్స్ ది కండక్టర్ ఇక్కడ ఏమవుతుంది కరెంట్ ఈజ్ కమింగ్ అవుట్ ఓకే ఫ్లక్స్ ఈజ్ గోయింగ్ ఫ్రమ్ right left to right here to the here from here to here from okay what happens because of the current is entering into the board this conductor start has the force of going like this force because of it is coming out this conductor start flowing like this. So how many conductors are there? So the force will be exerted here like this. Force will be exerted, force will be exerted, force will be exerted. How many conductors are cumulative conductors? Here, force will be exerted like this, force will be exerted like this, like this, like this. So cumulatively, this rotor starts rotating. Rotor starts rotating. That's why whenever we are switching on, start rotating. Cumulatively, what happens? Start going like this. Start going like this. Okay, here also we are having north pole, south pole. Okay, not only two pole. So north pole current, inside current. Wherever the inside current is there, okay. So right, three are there. One is indicates the direction of flux. Another one is indicate the direction of current, whether it is going towards the inside or outside. Another is force. Okay, Fleming's right hand rule. DC motor is working to Fleming's right hand rule. Okay, right. Now, so this force, a force is established. This force is cumulative force will rotate the rotor. Force will rotate the rotor. So this force is depending upon the BEEL sin theta. It also there because just you also know about principle. Okay, BEEL sin theta. So B is magnetic flux density. How much flux is available in the DC motor? I is nothing but amount of current flowing in the conductor. Where L is nothing but length of the current. Okay, so here K is nothing but flux density, magnetic flux density. Okay, I current in the conductor L, length of the conductor. Theta, angle between current and flux. Okay, so not only single conductor, we are having group of conductors. Cumulatively, the force exerted is right side of the cumulatively, it is rotor starts rotating. So, BEEL sin theta. How much force is exerting? This the force which is exerting, force is developing in the conductor is depending upon this parameter, BEEL sin theta. Magnetic flux density current flowing in the conductor, length of the conductor, and angle between the current and flux. Okay, so this is about DC motor construction. Okay, and for this all principle of DC. Okay, and left side continue.
After lunch, కూర్చొని
Okay.
12:15
పన్నెండు only 10 minutes after that lunch sheet. So here DC generator is over, DC generator over. Okay, DC generator you are done. DC generator you are done. So you can easily remember AC generator. AC generator. So if you know the DC generator, it is easily AC generator. What is the difference between DC and AC? What is the difference between DC generator and AC generator? The DC what does? DC generator, AC generator. What is the difference between them? This is common. Only DC is changed as AC. Okay. So here my question is, the EMF generated in the DC generator is AC or DC? The EMF generated in the DC generator is AC or DC? AC. So we are using commutator to convert the AC to DC. So for the AC generator, we doesn't require commutator now. For the AC generator, we doesn't require commutator. Why? There is no need of converting AC to DC. అవసరం లేదు కదా, ఎందుకంటే ఈఎంఎఫ్ జనరేటర్ డైరెక్ట్ ఏసీ జనరేట్ అవుతుంది కదా. ఏసీ జనరేట్ చేసినప్పుడు మళ్ళీ మనం ఏసీ జనరేట్ చేసినప్పుడు మళ్ళీ మనం కంప్యూటర్ ఎందుకు అవసరం లేదు కదా. కంప్యూటర్ is the device which convert AC to DC. So one thing, there is no commutator is required in the AC generator. Okay, that is a commutator. Brushes ఉంటాయి. Okay, so principles ఏమని చెప్పాను కదా. What it will do, AC generator is a machine which will convert mechanical energy into electrical energy. Okay, so here see, north south conductor. DC generator what we have done? Conductor rotating, generator, conductor rotating the magnetic field, conductor rotating in the magnetic field and EMF is induced. Conductor rotating in the magnetic field and EMF is induced. Okay, now AC generator the AC antunnanu kada, only by simplicity. Okay, in order to get easy conversion. Okay, what I am doing now? Okay, DC generator, if you see DC generator, then DC generator. Yes. Here we are having field. Yes. North, south. Conductors are here. Now what I am doing, I am interchanging their places. AC generator. For AC generator, I am interchanging their places. What the meaning? In the rotor, I am in the field. Okay, like this. In the rotor, I manage the field. Okay, so here we are having the flux. Okay, here I am having the flux. Here is the conductor. What is the difference between them? Just have interchange their location. Okay, field is in the rotor. Conductor in the stator. I have interchanged. There is no commutator here. Okay, so That is the difference between AC generator and AC generator. So, ఆ diagram draw చేసినాక మీరు వెళ్ళండి. కావాలి మనిషికి right? Alternative diagram AC generator.
ఆల్టర్నేట్ ఇంత ఉండదురా అసలు వెరీ సిన్సియర్
డైరెక్ట్ ఎగ్జామ్ రాజస్థాన్ రాదు ప్రాక్టీస్ చేయాలి
ల్యాప్టాప్ మోసిచ్చాడు మా హెచ్పికే ఇవ్వలేదు
రాజేసిన వాళ్ళే వెళ్తారు లక్ష నిజాలు ఇక్కడ కూర్చుంటారు
సూర్య వచ్చాడ్రా సూర్య లోకి వచ్చాడ్రా 100 ఏళ్ళ రేడికి సూర్య అన్నం లేదా కనిపించాడ్రా ప్రత్యక్ష ల్యాప్టాప్ లోపల కూడా మరి బయట షేప్ లో పెట్టేస్తాను శబ్దం
Conductors are available in the stator of the AC generator. Conductors are available in the stator of the generator. Field is available in the rotor. Field is available in the rotor. It is fixed. North pole, south pole, north pole, south pole. అది కూడా ఆబిద్ మా
Stop button, stop button.
Oh, पूरा बॉडी में लिंक तरी ఉంచింది కొంచెం లింక్ తరీ ఇక దేవరా
అది ఇప్పుడు వెళ్ళాలి లేచి దాని అట్లా వెళ్ళిపోతుంది వెళ్ళిపోతుంది 12:30
లేపు చెప్తాను సర్లే హలో సార్ లెక్చరర్ చూసుకుంటారు లెక్చరర్ చూసుకుంటారు సార్ మీరు మైక్ తీసుకో
సరే
I will explain after the lunch, but you will draw the diagrams.
తీసుకెళ్ళి After 2 days, okay. Okay. Okay, we'll meet after lunch.